Okay, this is how electroplating works. Now, what we're doing here is electroplating an iron spoon, okay? And we have a rod of pure silver over here. And these two things are sitting in a solution of silver nitrate. And we have a cell connected, which is making the silver positively charged and the spoon negatively charged. Okay, now this is silver nitrate, which means there are ions of silver, that's Ag, which has a positive charge, okay, floating around, and the nitrate bit is NO3, right, which has a negative charge. Now, silver nitrate, as a solid sitting on the bench, is an ionic solid, or an ionic compound, and these two are bonded together. However, this is a solution, and in solution these ions separate, and the silver ion is free to flow wherever it wants, and the nitrate ion is free to flow wherever it wants. Okay, so because the silver ion is positively charged, it floats over here, and is because it's attracted to the negative spoon. Okay, so it flows over here and it hits the spoon. Okay, and it's still got a positive charge the moment it hits the spoon. However, the spoon is full of electrons. Okay, it's all negatively charged, you see, and what happens is that electron hops on to the silver ion that's just hit the spoon. And so the spoon loses an electron, okay? That electron has gone onto the silver ion, and it's no longer an ion now. An electron has negative charge, so it knocks out that positive charge that the silver ion used to have, and it's now a silver atom. It's no longer an ion because it's no longer got a charge. Okay, so we've got this situation. You now have an atom of silver stuck to the spoon. And that's how the spoon gets covered in a layer of silver. There are trillions and trillions of silver ions in this solution, and they all flow over here and hit the spoon, and that's how the spoon gains a layer of silver. Okay? Now, this cell is not an infinite supply of electrons for all these silver ions hitting the spoon. Okay, these electrons have to come from somewhere. They come from over here. Consider a single silver atom that starts its life on the surface of the silver rod. Okay? The whole rod, like a lump of silver, okay, is neutrally charged, and this silver atom on the surface of the silver rod, the atom still has its electron, okay, so it's not an ion yet, it's a silver atom on the surface of the rod. Okay, now the electron from that silver atom leaves and enters the rest of the rod. Okay, so it hops into the rod and it will flow around in this direction, and that turns this into an ion. Okay, and then it leaves the surface of the rod and enters a solution. Okay, it's now a silver ion in solution, and just like all the others, it's attracted to the negative spoon. So it comes over here, hits the surface of the spoon, gains an electron and becomes neutral, just like what happened here, and ends up coating the spoon with a layer of silver. Okay, so that's where the electrons come from. They come from silver atoms over here that entered the rod, and the electrons flow in this direction, like that. Okay, so because atoms of this silver rod are leaving it, it gets smaller over time. By the end of the electroplating, this whole silver rod has shrunk. Okay? And that's pretty much it. So just for clarity, the silver atoms that coat the spoon, some of them come from the silver nitrate solution, and some of them will have come, like this one, it's gone all the way from there, all the way over here, from the rod. Okay? And at the end of the experiment, you still have the same number of silver ions in the silver nitrate solution as you started with, but the ones from the silver nitrate solution that ended up coating the spoon have been replaced by ones from the rod. So by the end, the silver nitrate, the silver ions, which are part of the silver nitrate solution, some of them will have come from the silver rod. In fact, most of them probably. Maybe, look, this is not really that important, but maybe some of the silver ions that started as part of the silver nitrate solution will still be in solution at the end of the experiment. I don't know, it doesn't really matter. Probably most of them from the solution will have ended up on the spoon. And so most of the ones in the solution by the end of the experiment will have come from the rod. But I'm sure some of the ones from the rod will end up on the spoon as well. Look, all that doesn't matter. I'm overcomplicating it. That's it. That's how it works. Electroplating is not that difficult to understand, right? There's no need to be intimidated by electroplating questions in your exam. Definitely. I'm sure you can understand this. I'll just recap it briefly and try and show how straightforward it is. Quite simply, positively charged silver ions in solution are attracted to the negative spoon. They hit the spoon, an electron from the spoon jumps onto them and turns them from positive to neutral to a silver atom. Okay? And then it's stuck on the spoon forever. And that's what happens here. What happens over here is atoms that were on the surface of the silver rod, they lose an electron, it goes into the rod, which flows around in this direction. The atom is now an ion, it enters a solution, and it flows over here and sticks the spoon, just like here. And then it gains electrons and it's part of the spoon. That's it. I'll just quickly mention oxidation and reduction. Have you heard of oil rig? That means oxidation is loss, reduction is gain. Okay? Oxidation is loss, reduction is gain. Gain and loss of what? Of electrons. Okay? So, because this silver ion here comes over here and it gains an electron, it's being reduced. Reduction is gain. So, reduction is what's going on here, and over here, oxidation is loss of electrons. That silver atom lost an electron, it went over there and became an ion, and so oxidation is loss. Oxidation is happening over here. Okay? There you go. That is how to electroplate an iron spoon with silver.